Welcome to the explainer that is going to turn you into the John Wick of Cambridge physics. Seriously, the boogeyman of grades. Because here is the core concept of today's session. When the examiners push you out of your comfort zone, you push back with perfect answers. We are diving deep into the absolute insider strategy for mastering Cambridge physics. Whether you're tackling syllabus code 9702, 0625, 0652, 0654, or 5054, we are unpacking the equations of motion, the absolute intricacies of the freefall experiment, and the brutal complexities of projectile motion. If you have ever felt like you totally know the physics, you have literally memorized every single formula, but your exam marks just aren't reflecting your actual effort, you are in the exact right place. Today, we are not just looking at standard textbook physics. We are cracking open the examiner's playbook. We are going to decode exactly how Cambridge examiners assess your understanding and award those crucial marks. Let's not waste a single second and get right into the mechanics of pure exam success.
Okay, let's dive into this powerful insight straight from a senior examiner. They literally said the difference between a B and an A star in physics often comes down to how well you understand equations of motion in unfamiliar contexts. To really understand this, I want you to imagine a real Cambridge past paper question, let's say a classic 0625 paper. We've got a dynamic split-screen situation here. On one side, we have our first student, Alex. Alex is smart, but Alex overloads every answer with raw physics facts. Total formula vomit, but absolutely zero analysis. On the other side, we have Sam. Sam rushes the paper completely, scanning right past the command words and missing the core requirements of the question entirely. What happens to both of them? A sea of red pen marks. The examiners do not just want to see if you can plug numbers into a familiar equation you've practiced 100 times. They actively design questions to push you out of your comfort zone. They want to see what happens when a standard freefall scenario is suddenly placed in an environment you have never ever seen before. Your goal is no longer just memorization. Your goal is adaptability, and that is exactly what we're going to build. To get you out of the red ink and into that A-star tier, we are going to reconstruct your entire approach into 4 critical phases. First, core principles and connections. Second, the procedural framework. Third, evaluation and critical analysis. And finally, top examiner warnings. We are covering the whole shebang. Let's kick things off with Section 1, Core Principles and Connections. This is the strategy reveal where we decode the actual cognitive skills you are being tested on. The assessment objectives you face target 3 highly distinct cognitive domains. First up, knowledge and understanding. This is your baseline. Do you know the precise definitions? Do you know the foundational equations of motion? Yes? Great. But as we saw with our student Alex earlier, that is just the beginning. Then comes application. Can you apply these equations to a specific, tangible freefall experiment? Can you map theoretical causal relationships to a physical scenario? And finally, the highest tier of all, analysis. This is where you are examining the data, recognizing patterns in projectile motion, and breaking a complex system down into its component parts. If you are only studying for knowledge, you are literally leaving 2/3 of your marks on the table. To bridge this gap, top students use the PEL framework: point, evidence, explanation, link. You make your physics point, you provide the mathematical or theoretical evidence, you explain the mechanism, and you link it right back to the command word of the question. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along, this leads us to an absolutely crucial strategy. Principal examiner reports explicitly state that candidates who connect concepts across different topics achieve significantly higher marks. What does this mean in practice when you're using that PEL framework we just talked about? It means the conceptual framework for equations of motion doesn't exist in a vacuum. When you are looking at a projectile motion question, top candidates aren't just thinking about simple kinematics. They are seamlessly integrating principles of energy conservation or fluid dynamics. They see the causal relationships between the forces acting on the projectile and the resulting equations of motion. It is this integration, this ability to zoom out and see the entire physics landscape, that proves to the examiner you have achieved true mastery. Always be asking yourself, what other area of the syllabus is secretly at play in this specific question? Let's transition right into Section 2, the procedural framework. This is where the transformation happens, where we take those red pen marks and turn them into glorious green check marks. This step-by-step sequence brilliantly illustrates the physics success blueprint. It is the exact procedural framework top candidates use when opening their exam papers. Think back to our students, Alex and Sam.
If we gave them 60 seconds to rewrite their flawed answers, this is the blueprint they'd use. Step 1. Deconstruct the question. What command word is actually being used? Calculate, describe, or evaluate. Step 2. Extract relevant data. Pull the specific numbers and conditions out of the narrative. Step 3. Select your analytical framework. Which principles and equations actually apply here? Step 4. Execute with clear notation. This is where you apply the Peel method and show your working so clearly that the examiner can follow your exact train of thought. And Step 5. Present with correct terminology. Verify your results and put them in the appropriate format. This isn't just good advice, guys. This is literally how the mark scheme is built from the ground up. If you skip steps and just jump to an answer like Sam did, you lose the method marks, which are the absolute easiest marks to secure.
So the crucial point within this blueprint is data interpretation. In a complex free-fall experiment question, you are going to be bombarded with texts, tables, and graphs. Data interpretation isn't just about casually reading numbers off a page. It is about extracting that data accurately, interpreting the underlying relationships, like, say, the relationship between displacement and time squared, and then drawing rock-solid evidence-based conclusions. When you look at a table of results from a projectile experiment, your brain needs to automatically start seeking out the trends and anomalies. The examiners are specifically testing your ability to handle raw data and transform it into meaningful physics. This is exactly why those step-by-step rewrites transform a failing grade into an A star. Section 3, Evaluation and Critical Analysis. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, welcome to the interactive workshop phase of our explainer. We are putting you to the test right now. Top-scoring candidates separate themselves by employing evaluative thinking. This means questioning assumptions, considering different perspectives, and justifying decisions with hard evidence. We're going to run Challenge 1, Data Scan. Imagine a complex physics data source is on the board right now with a 60-second visual countdown ticking away. Your job is to extract the core trend. Go. The assessment framework comprises 3 levels: descriptive, analytical, and evaluative. Describing a free-fall experiment is easy. Analyzing the data is a bit harder, but evaluating the entire approach, that demands higher-order skills. It means you aren't just a passive calculator punching in numbers, you are acting like a real physicist. You are evaluating alternative methods, comparing different theoretical approaches, and making justified recommendations based on your systematic analysis, while that clock is ticking down. Time's up? Did you spot the trend? Let's roll right into Challenge 2, Find the Flaw. I'm going to outline a flawed sample physics paragraph mentally for you, and your job is to identify the sentence losing marks based on this checklist. When analyzing a freefall or projectile motion experiment, use this to evaluate the quality of your evidence. First, identify the limitations of the experimental setup. Did human reaction time affect the stopwatch reading? Second, note the assumptions made. Are we assuming air resistance is completely negligible? If so, why, and is that valid in this specific scenario? Third, consider alternative interpretations of the data. And finally, determine the effect of all these factors on your final conclusions. If your assumed value for gravity is slightly off due to equipment limitations, how exactly does that propagate through your equations of motion? If a student's answer just says, the experiment was good, but maybe had some human error, that is the flaw. It's too vague. You need to articulate these precise points clearly in your exam, and examiners will be absolutely thrilled. And now for Challenge 3, Speed Writing. You have 30 seconds to mentally draft one perfect Peel paragraph. Ready? Go. Here is an absolute examiner alert to keep in mind while you draft. The most common trap students fall into is providing a generic response instead of a context-specific answer. Let's say you get a question about a projectile launched on another planet. A generic answer just lists standard Earth-based projectile facts. Boom, 0 marks. A context-specific answer meticulously links every single point directly to the given scenario: the specific gravity of that newly discovered planet, the specific launch angle provided, the specific atmospheric density. You must always link your physics to the exact context of the question. Generic answers, even if they are factually true in a textbook, will score nothing if they don't apply to the specific scenario the examiner has crafted for you. Stop the clock. How did your paragraph hold up? Did you link it back to the specific context? Finally, we have reached Section 4,
Top examiner warnings. This is where we bring everything together into the final system and look at the most critical red flags straight from Cambridge. We are looking at the complete physics answering system. Examiners have highlighted 3 major mistakes that ruin grades. Just 3. But these 3 mistakes cost students easy marks every single year, paper after paper. To combat this, we have 3 rules that absolutely guaranteed top marks if you follow them. Rule number 1, command word decoding. You must know exactly what the question is asking. Rule number 2, Peel framework application. Structure your thoughts so the examiner can't help but give you the mark. And rule number 3, the time management matrix. Knowing when to move on is just as important as knowing the physics. Let's break down the mistakes that happen when you ignore these rules.
Here they are, the top 3 mistakes straight from the examiner reports. Mistake number 1, forgetting to include proper format in your equations of motion calculations. This means leaving out units or using the wrong number of significant figures. It is literally throwing away marks you already earned. Mistake number 2, failing to check format and presentation. Presentation follows strict conventions. Proper headings in your tables, correct terminology, appropriate formats, and crystal clear annotation on your graphs are totally non-negotiable. If your working is a mess, the examiner cannot and will not award method marks. And mistake number 3, which we just hammered home during the speed writing challenge, providing answers that are not specific to the context given. Read the scenario, live in the scenario. Apply your principles only to that scenario. Do not be like Alex or Sam.
So how do you remember all of this under the intense pressure of the exam room? Here is a powerful memory hack. To ensure you never miss these procedural steps, create your own custom mnemonic using the first letters of the key terms for equations of motion and our procedural framework. Whether it's the classic SUVAT for your variables, displacement, initial and final velocity, acceleration, time, or a custom acronym for the steps we discussed, deconstruct, extract, select, execute, present, having a mental checklist ensures that absolute panic doesn't override your preparation. When you feel stuck on a freefall question, you just write your mnemonic at the top of the page and follow your own instructions step by step. It grounds you in the systematic process. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. As we wrap up this explainer, I want to leave you with this final, crucial question. When faced with an unfamiliar physics context, because you know for a fact Cambridge will give you one, will you freeze up and rely on generic facts, or will you step back and execute the method mark strategy? Will you deconstruct, extract, and analyze? The A-star is reserved for those who choose the latter. Take this framework, apply it to your very next set of past paper questions on projectiles and freefall, and watch how it completely transforms your approach. Keep evaluating, keep connecting the topics, and keep practicing. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.